Hello everyone. In this session, we are going to talk about pseudo force. But before we talk about pseudo force, we have to understand the concept of inertial frame of reference and non-inertial frame of reference. What is an inertial frame of reference? Inertial frame of reference is a frame of reference which is at rest or which moves with a constant velocity. While the non-inertial frame of reference is the frame of reference which accelerates. Okay, it is not in a uniform motion or it is not at rest. And in the case of inertial frame of reference, Newton's first two laws hold good. And in the non-inertial frame of reference, Newton's first two laws don't hold good. So in the second point, this second point we will discuss in more detail now. Okay, so to understand the meaning of this second point, let's understand, let's look at one example. Suppose I have a block which is attached to a string. Okay, let the mass of the block is m. Okay, and this whole system is at rest. Okay, so what you will if you draw the free body diagram, you will see that there is a tension force upward and there is mg force downwards, that is the gravitational force. Now T is equal to mg. Okay, because this whole block system is not moving, the block is not moving up or down, it is at rest, so that means total force acting on it must be 0. So T is equal to mg, right? So this is in an inertial frame of reference. Now what will happen if I keep this system in some kind of box and this box is accelerating upwards with the acceleration a0? Okay, then what will happen? So now the tension force will be different. For example, see here, if I draw the free body diagram in this case, then there will be tension upwards, mg force downwards, and then there is an acceleration in upward direction of a0. That means T must be greater than mg, and since T must be greater than mg, the acceleration should be T minus mg is equal to ma0. So this T is equal to mg plus ma0. So this is the tension force in this case. Now this free body diagram is drawn by the person who is standing outside the box. Okay, so outside the box as in the inertial frame of reference, the person is itself not standing inside the box. So T is equal to mg plus m0. This is according to the inertial frame when the box is accelerating. Okay, so let me erase this one. Now what if the observer is inside the box? If the observer is inside the box, let's say the observed tension is T dash upwards, so then he will say that it is T dash is equal to mg, because the free body diagram will look like this: T dash upward and mg force downwards, so both are equal in magnitude. Okay, so T dash is equal to mg will be said by this observer. But then this tension T dash is different than this tension T. Okay, it is not same. Then, and obviously the rope should have only one tension. Then how is it possible? The thing is that this tension T dash is not the correct one. Here the Newton's second law cannot be applied in the case of non-accelerating frame. Oh, sorry, in the case of accelerating frame of reference. So here, to make this law valid, you have to apply a force, okay, additional force ma0. So if I add this additional term, then this tension T dash will be equal to T, and then our case will be valid. So T dash must be mg plus ma0. Okay, this equation, in this case we are adding extra term here ma0. So now ma0 we applied downwards, ma0. So this is T dash and this is mg, and this will be equal to T dash, that is T dash is equal to mg plus ma0 if the ma0 force direction is downwards. That means in the opposite direction of the acceleration of the block, we have to apply this force ma0 in the free body diagram. So that means this additional term should be added, that is minus ma0 bar. And this additional term is itself a pseudo force. Okay, so this is a additional force that you have to apply for accelerating frame of reference. In the next session, we will do some problems based on pseudo force.